Okay, this is going to be fun today. I got to tell you, I've been looking forward to this particular hangout, even though we've talked about this problem so many times. This is one of my all-time favorite problems with anything I've ever done on the internet. I even happen to kind of like it better than 0.99 repeat equals 1 because that gets into some advanced calculus and some other stuff. This, however, is basic algebra and just math, simple maths that we've all kind of learned and then forgot about when these kind of questions come up. But anyways, welcome guys. We got the ever sagacious Landon Curt Noll with us today. He is one of the most world-renowned mathematicians, at least in our hearts. Let's see, computer scientist, amateur astronomer, I don't know, computer science, I don't know, whatever you got. Chemistry, biology, physiology. And by the way, I did once again, I did 5% of the graphics here, so this should be really awesome. So before we started, I asked in the live chat before we began a question. I said, when in mathematics can you have a relationship of 0 equal to 1? And I thought it was funny that people changed it to 0 factorial. Didn't ask about factorial. There's an answer to this. It's actually there's something called the zero ring in ring theory, where you have the additive identity. Yeah, is it the additive identity or the multiplicative identity? It's just identity. Well, just the identity. So you have unit ring. Right. Wait, they can't hear. Can you guys hear me? Oh, they can't hear Landon. Strange. I can hear you just fine. Can you? I think I only hear 5% of you. Yeah. Why can't they hear? I hear you just fine. I'm green across the board when you talk. Yeah, they see the hi. This is liberating 101. Well, this is kind of bizarre because when you talk, I can hear you on my desktop just fine. I had one job. This is why I need a producer. All right, let's figure this out. Why would they not be able to hear you? I mean, I literally can see you talking on my meter here. Oh, somebody pointed out over the reals over the integers. There's a 0 equals 1 thing. So, okay. We're going to get into that one of these days, set theory. We're going to talk about rings, integers, rationals, fields. Yeah. But let's try to figure out, before we get going on this, let's see why they can't hear you. The desktop audio is good. I got the NDI source. We're not even on NDI. Where's Bull when you need him? Yeah, we need somebody to do the other 95% of this particular episode. We're using Zoom here, so it should be just absolutely fine. Like literally everything was good on my end. He's got a dry board. I'm not gonna talk the entire time. I mean, yeah, he could write, but no, I want him to guide us a little bit here. No, it's not a separate audio stream. It's one Zoom hangout. Speakers, desktop audio. Yeah, I can hear you just fine, and it shows you on my desktop audio. No one's hearing you, except for me, and I have my audio level. No, it's not. It's not on your end. If I can hear you, it's not a problem on your end. But I can see you on my desktop audio like I normally do anybody else. Yeah, twist. Landa was never there. Yeah. Well, this is unfortunate here. It would have to be on my end. Go ahead. Try to exit and come back in. I don't know. I don't know why that should matter though, because if he's streaming to the Zoom and I see it as my desktop audio, that's going to be streaming out because it's coming over to the same thing. Because literally everything is right on my end, on my preamp and everything. So. Yeah, I don't think Landon knows sign language though, so yeah. This is what happens when somebody leaves. It gets all wonky, I know. But I don't want to mess with it because once he comes back it'll all be fixed. Alright, so did you guys hear the ding dong? Now can you hear him? Get a little we'll find out in a second here. It takes about 30 seconds to update here. Nope. I'm at a loss here because it literally. Yeah, we could use Skype. Yeah, we could use Skype and do it as the NDI source. Do you have? Yeah, let's go Skype, I guess. All right, so give us a second, guys. Let me log in here. While we're doing this, why don't you guys actually send this out so people can come join us? This is gonna be a fun discussion once we get it going. Do I have you on my Skype? Message me your Skype and I'll add you because I don't think I have you on Skype. It doesn't come up. Steve McRae. Yeah, believe it or not, that's actually my real name. The one with the striped shirt I'm yelling at right now. Yeah. Hi. Oh, yes, that's you. Okay. Now I saw that. Accept. Call. So. Love that sound. Okay. Yeah, I'm going to terminate Zoom right now. So give me a sec. Bye, Zoom. Okay, so you guys on the outside should be able to hear me real quick. I'm going to bring in... Well, I don't know. I don't think I have to bring in your audio, so... Let me see if they hear that, then I'll bring your video in right now, though. Alright, I'm going to get you a video source right now while I was waiting for you to hear you. Oh, there's an echo. I'll get rid of the echo, I think. Wait. Alright. The echo should be gone right now, but I haven't brought him in yet, so I got to get you on an NDI source. So add source. Real-time troubleshooting again. And woohoo. Alright, so I brought you in.
Testing. So are they hearing us now?
Yeah, I'm gonna check. Yeah, so if you guys can hear him now, let me know.
Good morning, good afternoon, or good evening, depending on your time zone and latitude. And attitude, too. Sometimes people, and maybe, I should say maybe sleep schedule, too, because some people, morning is a sleep thing, not a...
Let me change my settings.
A time thing.
All right, so I brought myself in here. All right, I think they did it. Yay!
So, good morning, good
Woo!
afternoon, or good evening, depending on your time zone, latitude, attitude, and perhaps sleep schedule. Excuse me. Hello from your friendly secular astronomer. So, do people hear that?
I think they did. Yes, yes, we're looking good.
Excellent.
Yay!
All right. So this is
Whew.
this is I guess I could claim 5% of getting it started by suggesting a program I don't necessarily like, but hey, it's working. So there you go. We're at least 2 sigma certain now of it. So let's get started again. You asked the question, and when it's 0 = 1, and I responded when you're on one answer is when you're on the unit ring.
Right. So the question that I asked in the audience, when is 0 = 1, is for your identity on your unit ring. But anyways, that's a different topic altogether. We'll get into some ring stuff later on, and some what's the difference between a field and a Building group, distribution of multiplication over addition, closure,
Counter
identity,
sets,
counter
all
set,
that
all
good.
that fun stuff that I tried learning one time and said, this is really difficult. So
But it is important for people who get all messed up about infinities, right? Don't be so up in arms and get your undies in a bunch about an infinity. Infinities are nice, normal mathematical objects. Well, I shouldn't say normal. They are nice mathematical objects you can handle if you know what you're doing.
I guess people tell me to boost up my audio a little bit, so I'm gonna turn my audio
Boost
up a
up
little
your.
bit.
Is my audio okay?
Yeah, you're probably a little high. So what I'm gonna do is I'm gonna turn you down a little bit, so they have to turn up their volume on their end.
I could go lower like
Because
that.
when I turn down my gain, they can turn down.
I thought my bass was no.
Yeah, pump up the bass.
Okay.
Oh, I'm too loud.
All right. All right. All right. All right. Okay. So let's get started, shall we?
Yeah, I kicked down your volume quite a bit. All right, go ahead. So, like I said, I'm kicking down your audio. You're
Okay.
good.
So we're going to basically talk about and what I think people are going to be surprised by some of our answers, but I think the confusion over the question that Steve put out, which is a kind of one of these common memes on the internet, comes from the fact that people don't understand what mathematicians do, and they don't understand. So if I think it's going to boil down to basically this kind of a system, right, where you have something called arithmetic. I see there, arithmetic, versus you have something like mathematics. The problem is that the way we teach math in school, we spend so much darn time on arithmetic that people think that all mathematicians do is sit around and do arithmetic problems. No, right? It's not the truth. Some of the thing, the difference between calculation and computation. So mathematicians do mathematics. Arithmetic is a tool. Just like let's say you're writing a novel, right? You're going to use spelling and grammar, or misuse them depending on what type of thing you're doing, and those are tools that help to do literature, right? So literature is not spelling and grammar, or spelling or penmanship. Arithmetic is sort of like the penmanship of mathematicians. Calculation, adding 2 and 2, is a very trivial part of computation, right? And if you're going to go and prove a certain number is prime of certain forms, let's say, or find a new largest known prime, you're going to be involved in computation. You actually can publish journal articles about computation, whereas you can't publish journal articles saying, hey, 2 + 3 is 5 for some values of 2 and 3 and plus.
But it's true.
Yes, well, true for some axiomatic system. So there's a difference between procedure and algorithm. And there's a difference between convention and axioms. So when someone does poses a question, and it's kind of a puzzle, right? That they'll sit there and say, they'll write this. Let's see. They'll write that. And they'll say, what is that, right? And if you're snarky, you say, that's a bunch of lines on the board. And you say, hey, come on, be nicer, right? And you say, well, okay, this is a couple of values and a couple of operators. And they say, no, what is it? What does it equal, right? And the answer depends upon convention and the order of procedures. It's a calculation problem. It's not a mathematical problem per se. It's not computation in the normal sense. There are algorithms for evaluating that, and there are axioms that allow you to do that. But this is not what mathematicians mostly do. Mathematicians take stuff like this, but they're writing novels, much like an author takes things like spelling and forms words to convey ideas. That's the same thing that mathematicians do. So there's a lot of confusion about that. So the answer, of course, the question is what is this equal to? And if you are a logician, you will say, well, what are my rules? What are my order of procedures? What are my conventions down here? And that can tell you how to apply an algorithm using axioms to evaluate this, right? Because the question is, what is this equal? So basically, people want to say, well, put an equal sign there and put an equivalent value, right? And the question is this, how do you answer this problem, right? Do you say that this is 9, or do you say this is 5?
Just real quick for the people triggering for the spelling thing, I think the A should be an E on arithmetic.
Oh, I'm sorry. That's right.
He was probably going for arithmetical or something. I don't know.
Yep. I'm sorry. It is. Never mind. That is a bad A, or a bad E, depending on there. Yeah. So back to the thing on that there. So if you're talking about if you're talking about this evaluation, does it evaluate to 9 or does it evaluate to 5? Well, there are mathematically valid sets of rules that can produce the number 9, and there's valid mathematical rules that can produce the number 5. Steve, do you agree?
Oh, yeah, absolutely.
Yeah. But we have conventions. Much like if I say, spell the word color. Well, there are COLOR, COLOUR, and there are different conventions that say what you use, this one or this one. Just like there's different conventions on how you evaluate that.
Yeah, there's acceptable conventions and unacceptable. Like when you do a spelling contest, a word has to be spelled a certain way because that's the convention they're using to spell it that way.
Yes. Now, if I were to come back and replace this E with an A again, someone would say, you spelled it wrong. They identified I said arithmetic, spelled arithmetic up here, but I spelled it wrong, right? So you can convey information, it's just not the usual form you do it in, right? So we do the E there. The similar thing, on this thing here, do you take 10 minus 3, evaluate it to 7, plus 2 and get 9? Or do you get 10 minus 5, because you take 3.5 and get 5? Well, the question is, what's your convention?
Yeah. Now, normal convention obviously is going to be is going to be 5 for the solution of that. But again, we're going to be explaining why the order of operations is the way they are for that specific convention. But there might be other conventions out there where you'll take it directly as written. For example, if you ever, Landon remembers these days, but back when they used to have something called reverse Polish notation.
Mm-hmm.
Which was a unary type system where you had stack, and as you enter, as the problem was read as entered, It was a completely different way of doing that convention, because you would solve something completely different if it was written in reverse Polish notation as compared to what we would understand as being basic arithmetic.
Yeah, and one of the things, of course, is that if, for example, in a calculation system, where going from left to right, you would do 10 minus 3 to get 7, add 2 to get 9, right?
Mm-hmm.
If you have the addition operator happening first, you're going to value it to the 5.
I meant, by the way, 9, not 5. I meant 9. I said 5 earlier.
Yeah,
I made it. I made a mistake too.
So I was, man, I was trying to show that there are two different values. So notice I didn't say you were mathematically wrong.
Yeah.
Because we haven't gotten to what is your convention? How do you perform these calculations and do that sort of thing? And so there's a standard convention where you go, from left to right. And so you would say this thing is the value 10. You have a subtraction operator, and you take the next thing, object, which is 3. You perform that subtraction to get 7, and you take the next operator. So you're going from this to this, right? Mm-hmm. Is your idea. And so most likely, if you were to say 10 minus 3 plus 2 is 9, people would assume you are correct.
Right, because that's standard.
Yeah, it is a common convention that most people do. Now, I can say that for somebody who is used to reading in the opposite direction, right? They read from here to here, they might get confused and go the other direction. But again, the valuation is usually done from left to right. Now, one of the things that comes about, so we would say, we might even go so far as to say that 9 is the preferred value here.
I would say that 9 is the expected value.
Expected value, right?
Yeah, because when I asked this question on the poll, I made it very clear what was the expected answer, given that if this was on a test in California, because this is how Common Core is taught, and this is how in any standardized test, the way this equation is written, the way we're showing you, the expected answer is 9. That's the whole point of this question.
Yeah. Now, one of the things is that if you're trying to convey information to somebody, and you're trying to convey a set of operations, and you write it down like this, you don't want to be misleading, right? So we'll get into some things that are a bit trickier in this process. I mean, if, for example, one of the things is that notation matters, right? There's good notation, there's poor notation. So whenever someone starts using this little symbol, you probably know that you're in trouble, because again, this gets misinterpreted, right? So that's, if someone says 10 divided by 5, and they do it this way, divided by, let's say, 2. What are they saying? Well, oftentimes what people might prefer to do it is something like this, right? But in rarely in math journals will you see that symbol, the double dots with a line over it being used. Usually you'll say something like 5/2 like that.
Yeah, actually, the obelisk is actually forbidden by ASO standards. You can't use the obelisk any longer. It's considered to be a forbidden symbol, as they call it.
Yeah, and because it's misleading. So someone, so this is a preferred thing, and particularly if you're doing a fraction, to have a large bar, small bar. So you evaluate this and evaluate that, right?
Yeah.
Or what you might do is you might want to be explicit, but parentheses around things.
Yeah, it used to be that the obelisk, the problem with the obelisk was that it had a typesetting problems. This was the early 1900s, around 1917, I remember, that the obelisk could represent exactly that. It could be either a horizontal bar or what's called a vinculum, where it would be represented as 10 over 5. And so it would be very confusing, because that's how it was for a linear expression like that for the typesetting reasons. But the obelisk could actually be read multiple ways, which is
and you start doing this. if you start doing this kind of thing, and mixing your notation, then you get anything worse. So this I would say would be use of this is poor style.
Yeah,
And
it's ambiguous.
yeah, and so it leads to confusion. So when someone does some cute little problem and they come back and they say something like, oh, and they use also, by the way, typically this is not preferred for multiplication to x or the star, right? So when someone says what's this sort of thing, immediately your flags go up and say you're using poor notation. So before I answer that question, I want you to tell me exactly the order
Now,
operation.
how do you feel about using a dot? Because dot can also be using as a dot product for vectors. So how do you feel about that notation?
That notation of the dot, I think, is
pretty standard,
acceptable in mathematics, because the actual dot operator has an actual, if you look at the multiplication in like a vector space, the dot product makes sense.
Yes.
Right.
Okay. Yeah, I have no problem using the dot either. So
I
much prefer that over the x.
so generally, you don't want to be using this, and you don't want to be doing the x stuff, right? You don't. That's a poor standard. I mean, a better way, if you want to write it on a line, would be to 10/5/2 like that.
Yeah, those
right?
are called solidus, and so the slash represents the division operator.
Yeah, and then if you sit there and say, well, what I really meant was this, right? You do 10 like that, and you put parentheses around it to make it clear, you are aiding in the thing. You're aiding in what you're trying to convey, right? And typically, if you're programming, writing source code, putting parentheses can actually help convey the meaning rather than just to say, can I trick you up?
Yeah, I'm really a fan of parentheses. Normally, parentheses are used to change the order of operations. That's normally what they're used for. But I also can think they're great for grouping and just making it more explicitly easy to be read, even though it doesn't change anything. If you put the parentheses in, you're not doing anything mathematically wrong. People have said that I've actually had people argue, well, why you can't put in parentheses unless they change something. Well, no, you can put them in any time if you're trying to show somebody.
So this makes it clear what you're trying to do.
Right, it's less ambiguous.
That's saying I'm interested in one, because it's harder to find a convention for which you'd ignore parentheses, right? That's a thing. And I know there are cultures and there are practices that try to do the minimum necessary, like the notation that's supposed to be as small, compact as possible. I think that's a really poor way of communicating.
Well, probably back in the day when they had limited memory, you had to squeeze every drop of memory you can. So maybe.
Yeah, I mean, but bytes are fairly cheap these days. Yeah. But there's other situations. You sit there and say, okay, I get the thing about parentheses. In fact, there's a whole. I guess depending on how you do it, there's PEDMOS. I think it's
bid. Okay. Yeah.
EDMIS, I think it is.
MAS, PEDMOS.
MES.
PEMDAS. No, it's PEMDAS.
PEMDAS.
No, it's PEMDAS. PEMDAS.
PEMDAS, right there.
Yes, and they also have BODMAS, BODMAS, BIDMAS, BIDMAS, and there's also one just called MDAS too, or PPMDAS too. But those are the main ones, right? Oh, there's BEDMOS too.
There's BEDMOS.
Yeah, it's BEDMOS. Yeah, so all these are acronyms to help people remember the order of operations, but they all mean the exact same thing. Even PEMDAS and BODMAS, they are identical. And I think what happens in the educational system is that teachers are not properly explaining that it's not to be taken literally as PEMD, but as PEM or D, depending on order, how they expressed in read left to right, and then AS. So that's how I write it. I write it just like that with parentheses, so people know that the M and D are interchangeable and the A and S are interchangeable.
So it's parentheses, exponentiation, along. So this matters. I mean, so when you do conventions, right? And if I write something like -2 to the third power.
Yeah, real quick. Order O is for, people are asking. O is for order. I is for index. They're called indexicals. Would be the same as the exponent.
And so just if you understand, things like other speaking countries, like for example, UK, India, Bangladesh, Australia use you might hear BODMAS more. BIDMAS is used in some West African countries, and New Zealand uses BEDMAS, right? But it's really a matter of convention stuff. The thing you have to be careful of is, what does this actually mean, right? And so if you look at something like this,
Yeah, let's see if they can answer. Let's turn that over to the live chat real quick. See if they can what they think that is before you actually tell them. Now, I will give you a hint. The multiplication symbol there is a unary operator that's factored in last. Okay, so if you can remember that, you're probably gonna get this right.
So what is the value?
Boolinator doesn't count. Boolinator doesn't get to answer these questions. All right, see what they answer here. Ignore Boolinator. He cheats.
I mean, and also we might as well add this value here, right? Let's do that symbol as well. So you got two. I've tried. You got two questions. What's the answer to the first question? And by answer meaning, what does this evaluate to?
Right. Yeah, these are called. By the way, these are called expressions. Just so people can know, an expression is something that doesn't have an equal sign. So the difference between a equation and an expression is an expression will not have the equation sign, an equal sign. An equation will have an equal sign. Just a little fun fact there. So they're getting it right. So they're getting the negative 8s are getting it right, but then they're saying 9 for the other one.
Yeah. So Steve, go ahead.
Well, it's not right, because the way you would do this is the first one is going to be, you do the explanation first. So 2 raised to the third power is going to be 8. Then you have the unary operators, -8. The other one you're going to do the same way. You're going to have 3 squared, which is going to be 9, and then the unary operator is applicable to it. So you have -9.
Okay. So the explanation in the common convention is there. Now you can have a set of rules, a set of axioms where these don't evaluate this way. They evaluate where this happens first, right? And so -3 squared becomes 9. But that's not a normal
right. So
common
this is where
convention.
people get confused. What they think the expected answer is going to be 8 or 9. Okay, and the reason it's not is because you have to do the explanation first. What it's asking for is not 2 raised to the third. It's asking if you take 2 and you raise it to the third, and then you make that a negative sign. It's not asking what the entire expression is doing. So if you write this as -2, or excuse me, negative parentheses 2/3, 2 raised to the third, 2 raised to the third. That's what you're evaluating when you see that.
Right.
Those are different things. Can people see that?
Right. Yeah. So this. Let me write the different value. Right. The different value is going to be -2 parentheses.
That's
the
fine.
Third power.
There you go. Yeah. That's a different thing altogether. I think people are getting those confused.
Now it turns out that numerically, -2 times -2 times -2 turns out to be -8.
Yeah, that's a coincidence.
Yeah,
because that's for an odd number. If it's even, it's not going to work that way.
Right, but if we did it this way, we said -3 squared and 3 squared negative, right?
Right.
This is going to, using common conventions and procedures, this is going to evaluate to 9.
Right.
This is going to evaluate to -9.
Right, and that's why the difference between even and an odd exponent. So this is what I think gets people really confused, is they see something like one of them is going to work out to let's say you have -2 raised to the third, you're going to get -8, but that's a coincidence, because if you don't want to look at it that way. What you want to do is the exponentiation first, and then apply that operator. So -2/3 obviously is going to be -8. -3 squared is going to be -9. You're not -3 squared is not saying what is -3 squared. It's saying 3 squared and then the negative of that.
Yeah,
is a way of looking at it.
Yeah. So let's try some other sets here to figure out, with this business. So
I hope they got that. I hope they understood that.
So this thing of -3 squared is one of our little items. Let's look at this case here. If I do this 1/2 m. right?
I read that as whatever m is, and then you're taking point 0.5 times point 0.5.
Right?
That's how I
Now,
read it.
now let's come back and say if I say 2m, what am I referring to?
You're 2 times the quantity m as 2 as a coefficient.
Sure. And in fact, if I said mc squared, what am I referring to? What's happening here?
2 times the square of c, or m times the
Uh,
square of c.
yes. And what's here is called implicit multiplication, right? This is not the value mc squared.
Right.
This is m times c squared. In fact, it's you might say if you're using a dot operator, you would do this, right? M dot c squared.
Yeah, so people can understand the distinction here. When you're reading MC squared, it's called implicit multiplication by juxtaposition, meaning that they're next to each other. So
Yes.
it's not showing that binary operator multiplication; it's implied. You can explicitly write it out with that dot. So if I decide to say I want to explicitly write it, I could write it as m dot c squared. Those two must solve for the same way, because changing from implicit to explicit in standard conventions, standard order of operations, cannot change the hierarchy of the order of operations, the precedence. It will not change it.
Yeah. So generally, in lots of math journals and physics journals in particular, the implicit multiplication by juxtaposition is considered to be of higher precedent are done first.
In some journals.
So they would see this as this expression here would be evaluated to 1 over 2m.
Which I want to make very clear for people is very fine in certain journals. They make it clear that, and they will say in there, if you're going to submit it, we are going to give implicit multiplication by juxtaposition a higher order of precedence. That's fine. There's nothing wrong with that. This is why you have to know what convention you work with. But there is still going to be one solution as written, depending on what convention you're using.
And so when you're submitting a paper to a journal, you should look at, they usually have something like a guide, author's guide, and they will tell you things like how they do the typesetting and how they want you to express things. Because it's 1 divided by 2m, or 1/2 m, you want to know what your audience is. And so there is, in many cases, the common notion that the implicit multiplication binds faster. So doing something like 1/2 mc squared, you start getting to problems where you sit there and say, well, okay, is that 1 divided by 2? Is that 1/2 mc squared, or is that 1 over 2 mc squared?
Write this on the board, because this is something that maybe people can relate to. Right? Kinetic energy, or Ke, equals 1/2 mv squared. Now, most people know that formula for kinetic energy, and they recognize it as you take v squared, the velocity squared, you times it by the mass, then you take half of that, right? They don't read it as 1 over that, because if anybody's taking physics, you don't read it as 1 over that. So that's in their, they'll get that. They'll say, oh, yeah, it makes perfectly sense that 1/2 mv squared is 0.5 times nv squared, right? You don't read it as 1 over 2 mv squared. Does that, and I hope that kind of helps people when we start talking about this actual problem, to understand you're doing the same thing in this particular problem that I asked for. You're taking 6 divided by 2 times the rest of it. You're not taking 6 over the rest of it, just like you're not taking 1 over the rest of it.
And the problem with this kind of notation is it's ambiguous, right? And particularly if I start doing stuff like this, right? That becomes even, what do I mean? And so so you'll find that most physicists will read this and say, well, you're obviously doing 1/2 mc squared.
Because convention, right? They know how to read it, right? It doesn't have to be explained to them, but it's still technically mathematically ambiguous.
Yes. So that's a problem. So this now again, this notion, there's an assumption that that variables have single letters, right? But when you start doing something like, if I say sin pi, I'm not taking s times I times n times pi, right? I now
Well, it
have
depends.
this.
Maybe you are. Maybe it's a math formula for like I don't know, speed times
The complex
impulse
operator.
times
Yeah, yeah.
newtons. I don't know.
Programmers might sit there and say, well, that's, pi, sine of pi, like that. Um, so you start to have things where there's bunches of letters that are not implicit multiplication, but can seem to be operators. So by the way, what's sine of pi?
Oh, I don't remember. Is it one or was it one?
Do people have in the chat room?
Um, is it? Oh, zero. It's zero. Sine of
Now,
pi is zero.
commonly
I
speaking,
hate that. It's either one or zero. I always get which one's which.
it's zero. It's zero.
It's zero.
It's
Yeah,
usually
it's zero.
zero. Now, commonly speaking, the sine function is usually evaluated in radians, right? So if you talk about pi degrees, you're not going to get zero, right? So one of the things in particular is you have to say, well, what are you doing? And usually when you're dealing with trig functions, almost always you're using that. If someone wanted to say sine of 30 degrees, they'll do sine of 30 and a little degree mark, which does not mean raise 30 to the zeroth power.
Yeah, because sine of pi is equal to zero, and then cosine of pi is equal to -1. Which, when you get into Euler's identity and Euler's formula, it's critical because you're going to get what is e to the x times e to the I x equals cosine I. Excuse me, e to the I theta equals cosine theta plus I sine theta, which ends up with 0 plus -1. So you end up with -1 for your identity. See, I remember. Oh my God, I remember something.
Yeah. So if I said sine of
this is fun for me. I like
100. I mean, Steve knows his stuff. He knows his stuff, right? So if you say sine of 180 degrees, right? What you're not asking to do is raise 180 to the zeroth power, which is 1, and take the sine of 1, right? This is mean to be sort of a unit operator, and it's considered to also be, form which is not preferred, right? So be careful using trig functions. Know you're dealing with radians and that sort of thing. Let's now take something that's a little bit more advanced. So we said that this sine of pi is 0, right? And if you remember, you got the little sine wave there, and this is 2 pi out here. So pi sits there, and so it comes back now around to 0. So what if I said sine squared pi?
How you so that'd be 0.
Yeah, because what do we mean by when we say sine something?
Well, sine pi is 0, and 0 squared is 0.
Yeah. So what we're really doing is we're saying take sine of pi parentheses and square that,
which is 0 times 0, or 0 raised to the 0. 0 squared, which is 0.
Yeah. Because the problem is if you say something like, let's take this notation here. And again, I apologize for the typos. This is what happens in real time. Sine of pi squared, like this, right? They're not saying that you do this function operator first and then you square it. They're saying take pi squared and then take the sine of pi squared and radians, which is something weird.
Yeah, we'll have to do a whole thing on unit circle one of these days on the difference between radians, gradians, and degrees. Yeah, I don't even the psi pi square is something completely different. I don't know.
That's minus 0.430 right, or something like that. So when we want to say this sine of pi squared, they put for whatever reason the operator is sitting there. By the way, this does not mean taking the sine of the sine of pi. That's not sine squared. This value here means this.
Yep.
And so there's a little case where now the exponentiation is now in the middle and not at the end, right? So you have to be careful about that. Now, some people, when they're typing, particularly if they're tweeting or various programming languages, they might say something like A up arrow B plus C. So if they said A up arrow B plus C, and they say, what is this? The answer you should probably say is, I don't know, what's your convention?
Yeah, because it could be read two different ways. Either A raised to the B plus the addition of C, or is it A raised to the quantity B plus C?
Yeah, well, actually, it gets even worse, right, for that. Because is this, for example, A to the B plus C?
Oh, it could be that too. Yeah.
Or is this A X or B plus C? Or is it that because this explanation usually binds tighter, right? So you would say this plus this, right? Now,
I read it as X. I read that as A raised to the B plus the addition of C.
Yes, this value here.
Yeah.
Now, in various programming languages, the up arrow and various symbolic systems, the up arrow refers to the XOR operator, and so you do A XOR B, and then you'd add C. And if what you're trying to do is A to the B plus C power, you're probably better off putting parentheses around things, right? So if this is what you meant, you're probably better off saying A up arrow B plus C parentheses. Now, by the way, there's also a convention for A, and they'll do double asterisk B plus C. Fortran and things like that use and Python so use that notation. And this is one of the problems sometimes when programmers, you talk with programmers who are used to how their programming language evaluates expressions, that you have to be careful about this sort of thing. If I'm tweeting this thing here, some people will read it this way, some people will read it that way. Right? So explanation has to be now in a journal. They would rarely let you get away with using this up arrow operator, because particularly if you're doing stuff with logic and so forth, that becomes even.
I like how you call it the up operator. I just call it a caret, but whatever.
Yeah, caret.
But see, this is these are all
Up
different ways
arrow,
of
up arrow.
yeah. Everybody just has their little quirks of how they read these things.
All arrow. So here's an example of another bit of notation you have to be careful about. There's concatenation operator. This is a really poor set of notations. So if I say 5 times 1, 2 plus 4.
Okay, like I said, I read that as this. I read that as X times 12 plus 4. So
right.
64.
Multiplication happens first, right?
Yep.
So this would be 60 plus 4 or 64.
Yeah, that's how I would read that particular notation.
Now there are languages where this is a Boolean operator, and not to be confused with Booleanator. Booleanator is a nice person. Boolean operator is a
Booleanator has operators named after him. That's how cool he really is.
Yes, exactly. So there are cases of this or this, right? And so the language would say you evaluate 5 times 1, that evaluates to true, and so the expression is true.
Now, would you ever catenate it such that you would have 5 times 1? Would it be 5 times 1 plus? How would you? I don't see the only way I could actually read that would be if 1 and 2 are combined for 12. How else would you do it for your
because this here
right
turns, what is that? If I do that, what does that turn into? So let's ask the chat room. What does I put parentheses around these things?
Okay, and I would read that as what, 30?
We are. Well, I guess it's a question about.
No. I'm sorry. Wait. No, it would be 56. I would read that as 56. I'm sorry. Is that right?
So what does the chat room see? It's parentheses 5.
I'm guessing 50. I'm just saying how I would read it. Let's see how the chat room says. I say 56.
Yeah, and permit me to put a dot here because I just really dislike the X.
Yeah, don't use X for yeah. So let's look at the chat room. See if I'm correct. Am I right on this chat room? Is it 56? On this catenation, you don't see it very often. Booleanator says 56, so Booleanator says.
Yeah. Now, of course, if this symbol here is a Boolean evaluation expression, then it's true, right? But if
Yeah,
we're
that's
talking about
that,
this
yeah,
as
yeah, because if it's Boolean, it's going to evaluate as true, right?
now, some people might sit there and say, well, okay, it depends on the precedent, because could this not be this?
Yeah, so that's the problem. Do you evaluate it as 56 or you evaluate it as true? What would be the
Right? This is 5 times 6 or 30.
right?
This one is 5 concatenate 6 or 56.
But yeah,
So what?
so how would you? But so I don't know the standard for programming. What that would read in a computer? Is it going to be read as 56 or is a Boolean operator for true?
Almost always, I mean, almost all languages, this double bar symbol is going to be a logical
Okay, so it's going to read
evaluation.
as true.
Yeah.
Okay,
So,
I would, like I said, that's why I get confused because I would personally read that as 56, but I'm not a
now,
computer.
mathematical convention, where this is concatenation, and you put parentheses around the two, you are really saying, I want to take the stuff on the left and evaluate the stuff on the right. So one might say that this operator has higher precedence, and you get this.
Gotcha. Okay.
But the case of when we take this out, right? When we evaluate something like this expression, because people look at this and what you should say is, that's a weird expression. Why are you writing it that way, right? If I really want to say 1 concatenate 2 plus 4, that's clearer, and you say that's done first,
Yeah.
right? So because we do this,
Well, that one I can only see that evaluating as 64.
and that turns to 64.
Yeah.
So this is concatenation between this side, and that happens first before the parentheses.
Gotcha.
And then you get to 56. So the answer is that this is a really poor choice of operators, and but when we say something like 56, we are doing an implicit concatenation, right?
But this is why it's important to know what domain you're in, whether you're talking about some kind of like mathematics, like real mathematics or real analytics, or you're doing programming language, and what programming language you're using, right? Again, different conventions.
Because we say, what is 56? And someone says, well, it's a number 1 greater than 55. Answer might be no. 50. This is hexadecimal, and that's the same as the decimal value 86, right?
Yeah.
So you got to be clear. What is your?
But there's always going to be a standard, right? The way I look at it, this Landon, and I may be off on this, but this is my personal opinion. If it's not expressed different than standard, the expectation is to read that as a standard 56 as a standard base 10 real number. There's an expectation for that, unless otherwise noted.
So I would ask the chat room, what is this expression evaluate to? 2 to the 3rd to the 4th power.
Now he's just being mean.
Right? And some people might also say this as 2 caret 3 caret or up arrow 4 or hat. Or if you're a Fortran or Python or those sort of things, you might do it that way. So what does this turn into?
Yeah, somebody's going to have to actually calculate this. This is going to be a very high number. We'll see if... you know what? I'm going to go... a sec.
So...
Yeah, it's a very high number. It's a very, very high number. See if anybody gets it. I'll read the actual what it actually is in plain text here in a second.
I can give you a value. It is not. It is not equal to 4096. You said 4096. You are probably using a convention that we don't expect.
Well, I just cheated it, and I put it in Wolfram Alpha. It comes up with 2 septillion, 470 sextillion, 851 quintillion, 639 quadrillion, 229 trillion, 258 billion, 349 million, 412,432 million tenths. So it's basically 2.4 raised to the 10 to the 24th power.
And of course, if you want to know how to evaluate how to
That's a
say
pretty high
things
number, by the way.
in the English language, you should use my my English names of numbers. Kahneman and I are credited with the convention of having being able to give the English name of integers of any size.
Hmm.
So what do we do when we do this sort of thing? What this is called? I mean, this is called you know it's sort of it's a stacked symbols, right? And the usual order is to go from top down. You don't come from bottom up. So what do we mean by that? Let's erase some of this stuff here. What typically with people when they write that, what they're intending for you to do is to say 2 to the 3 to the 4th power. Right? So that's 2 to the 81st power, right? They don't, if you want to say 2 cubed to the 4th power, you need to do this. Like that. So this evaluates from top down.
Now, so how do you get from 2? Okay, so there's 2 to the 81st. I'm coming up with 2 to the 20, 2 times 10 to the 24th.
Is not 3 to the 4th power 81?
Yeah, okay, that makes sense. Yeah. Yeah.
Right.
All right, so it would make sense 2 to the 81.
Right. So this here is 8 to the 4th. That happens to be 4,096.
Yep. Okay.
Right. But there is an actual on my website. I wrote a program in Perl. There's a name of the number program, and if you enter in this value there, using there, you will get 2 septillion 470.
Yeah. Right. Okay, so the same thing. That makes sense. Yes.
Right.
That's what I got.
851 quintillion, right. 659 quadrillion, blah blah blah.
Pretty damn high number.
Yeah. So there is a site here, and I don't know how you could might be able to.
I just evaluated it. So 2 raised to the 3rd raised to the 4th equals 2.4 times 10 to the 24th equals 2 to the 81st power. They're all equal. That's true.
Yeah. So is there a way I can put this in the chat here? You might be able to put this into the chat there. There's a website.
You have mod.
I don't have access to. You have to ask Susan about that. So this is a site here where it uses a Perl program to evaluate, and that's where if you type in that to the box, name and number, right? That's where you'll get the 2 septillion 417 sextillion 851 quadrillion 639 quadrillion, right? No, it's going to be 851 quintillion 639 quadrillion 259 trillion.
I put I put your Perl script in there. Oops.
Yeah. So that's a thing. And if you take the Perl script and import it yourself and run it yourself, you can. It limits basically because I don't want to have people do huge numbers. But if you on the other hand you wanted to know what happens if you raise that to the 10th power, what that name would be, right? You would click the power of 10. So that number power of 10, and you get to a really long 100 octobillion million. It's a really bad number, right?
Yep. Yeah, it's a really big number. I knew it was going to be a really big number. I just didn't know what it was.
So explanation goes from the top down, right? And some people think people that are used to reading this way would think you'd go bottom up, but it actually is top down for there.
Okay. Did you want to go to something else? Or you want to like dive into the actual 6 divided by 2 thing and kind of show people? Up to you. I don't know.
Okay. So which one? What's the actual problem that you?
6 divided by 2.
Okay, let me clear the
Yeah.
board here for stuff. So this was the problem, and explicitly, you had a very explicit way you asked the question,
I
right?
did. I wrote the way I wrote it was because I write. I usually I think about the questions pretty specifically, and I actually we're going to go over why I ask the questions the way I do. Sometimes I give two choices a lot of times, and I have a lot of people will say, "Well, that's a false dichotomy." By the way, let me explain to you something. It's not a false dichotomy be giving only two choices. It's only a false dichotomy if you're saying those are the only two choices that are physically possible, right? Logically
Yeah.
possible. So if I offer you, if I say to you, "Hey, Landon, come over for dinner. Do you want chicken or fish?" There are other ontological possibilities, clearly,
Yes.
but I'm not.
Yes.
But I'm not offering to you. So that's not a false dichotomy. That is,
Yes.
I'm only giving you two choices. And people say, "Well, why don't you ever offer the choice of neither or something like that?" Because I'm not interested in that particular choice. I'm just going to exclude it from my data set anyways. I'm only interested in the people that have position one way or another, right?
Yeah.
And I'm the agnostic saying this, so I understand these concepts. I'm not looking for the agnostic position on a lot of these concepts, these questions. I'm looking on here. I want to find the people that have believe this. I want to find the people that believe this. I'm not interested in the people that believe neither, because that's not what I'm going
Yeah.
for the data set. And a lot of
Yeah.
people claim that's a false dichotomy. It's
So
not.
yes, yeah, because the economy is, is apples or oranges. There's no foxing the pulse about it, because the answer to the question, do you want apples or oranges? The answer might be yes.
But when you're offered two, the point is when you're offered two things, I could also offer you grapes too, right, or something, or nectarines.
Yes.
There's other possibilities. A false dichotomy is this: you're either with us or against us, right? That's an either or, saying that because an either or is a logical operator, such that that's only two possibilities. It is the case. It is the case that you are either with us or you're against us. That is a false dichotomy. It is not
And
the case you can.
yeah.
It is not the case you can only have apples or oranges. That is only things that I'm offering to you as choices. And so there's a different things we're talking about. The ontological aspect of it is what is possible. What is being here. So
Yes. Do you want apples or oranges?
It's not a false dichotomy.
Is it? And this is a problem where English language and most languages have these levels of ambiguity, right? Mm-hmm. If you want to be more, try to be more exact, you might say, which of these two choices do you prefer?
Yeah, I thought about it. I might have to do it that way so people don't get all pissy.
Oranges.
Yeah, I might have to start wording it because I know people get triggered on these things, and it's just I had one person on my I read this on my community tab. One person was triggered as freaking A. I'm not going to curse this one. I don't want to get this particular video demonetized. But one person was really triggered by it. Why is there not an either option? Because I'm not interested in the neither option. It doesn't do me any good. All it is going to take away from the two data sets that I'm looking for, right? Because it's going to provide a third option, and I want a weighted average between the two. So. But anyways, on this particular, it's 9 or 1. Now, people can answer other questions, right?
Okay, so it's a 6.
And their answers, but...
So your expression is 6 divided by 2...
Parentheses.
Parentheses.
Yeah, but the way I asked this was on a California standardized test. No, there's no parentheses there. It's just 6 divided by 2, open parentheses. 1 plus 2, close parentheses. So I asked this on a standardized California test, what is the expected answer? There's only one solution to this. Equals. Because it's an equation. I put it in as equation. All right, so let's put it as x. Let's put the variable x there. So we're going to solve this for you the way it was supposed to be done with the order of operations, because this is an equation. No. Let me tell people that for a linear equation like this, there's only 3 possibilities: one solution, 0 solutions, or an infinite number of solutions.
Yes.
This equation cannot have 2 solutions.
Yes.
So it cannot be 1 or 9. It has to be one or the other. It can't be both.
And the problem is, what is x? If you're a smart aleck, you'd say x is a variable, or x is a value, or x is a single value, or x is a letter, right? But all those are valid stuff. But let's try to say, well, what is it? What is the value over here? Right?
All right, let's do it a couple different ways. Let's do it strictly by using like PEMDAS or order of operations.
Right. So this would turn into, the first thing we would do is we would evaluate this 1 plus 2 and put 3 here.
Now remember, the solidus here on the obelisk, where you see it written either way, we're going to be treating it exactly the same way. So we're just using the slash or the solidus. But all right, so that's the first step. So this would be the P in PEMDAS.
All right. So one of the things in particular you might want to do to be really clear is we might put the explicit, take this implicit multiply and make it explicit.
I was going to say that for later, but sure. Yeah. The reason being is if you have the implicit multiplication by juxtaposition, if you explicitly show that binary operator there of the multiplication, it has to evaluate for the same thing. So you can't change the order of operations just by making something explicit.
So we evaluate in the parentheses. We change the notation to explicit multiplication, and then we remove the parentheses. That's another operation, right?
Yep.
So parentheses 3 parentheses evaluates to 3.
Every number has implicit parentheses around it. 4 has implicit parentheses. They're just not shown.
So now we're going to do this from left to right. So 6 divided by 2 turns to 3, and 3 times 3 turns to 9.
And that is the only correct answer to the question as I asked it. Because again, I'm asking on a California standardized test, if you got this on a test question, what is the expectation? And this is the way it is asked on lower level arithmetics for Common Core. Yeah. Unfortunately, they're ambiguous, but that's how they do it. I wish they wouldn't. I wish they would explain to people better.
But I think again, when you see something like this happening, where you see somebody is putting in, and the worst thing is they might do something like this. They might do really poor notation. You might see on the internet where someone does this.
Which again is going to evaluate for 9, but it's a lot of people think that obelisk represents a vinculum, where it's going to be 6 over 2 parentheses 1 plus 2. They're treating that quantity, because what happens is on certain conventions, like when you have implicit multiplication by juxtaposition, that implicit multiplier binds stronger, they call it.
Yes.
So and the reason for they do that, there's a reason for that convention, and some calculators will evaluate it that way. It's not that the calculator is wrong. The calculator is right by it's using whatever orders it's programmed to use, but it's easier to write certain formulas into a calculator to be evaluated easier that way.
Yeah.
So there are reasons why people use those conventions. If you take a physics course and a math course, many times it's going to use that convention, that implicit multiplication is a higher order. But what people don't realize is that's only the math course or physics course you're taking that's using that convention. They think that has to be always the case, and they argue, well, no, implicit multiplication always has a higher binding. Well, no, it depends on what course you're taking. Two courses may teach math completely different, and it's fine either way. You just have to understand the concept.
Mathematically speaking, those are valid ways to evaluate an expression. It's just that one is more expected than the other. So when you see MV, you say, what is that? Well, physicists might say, mass times velocity, because they interpret M as mass, V as velocity, right? Mathematicians might say, well, you're multiplying M times V. A Unix head would say, oh, that's the move command.
Or it could be a half a part of a disjunction of or M or something else.
Yes, right.
I don't
know. So you have to understand, if you will, the domain you're operating in. You have to understand the conventions. And so someone sits there and say, what is this? The answer you should give them is, what operator conventions are you operating under?
I agree asking is great. But I also maintain, I have for years, that if no other explanations are given, if no other directive is given, the default is always to go to standard.
Yeah, and so I would say, what is this? I say it's probably 9, but it could be different if you used a different convention.
And I would answer the same thing.
Right? Yeah. Another person, you could be even snarkier and say, what is this? It's a string of characters. Right? What is this? It's a numerical expression, right? So you got to be careful. What is it? What do you mean? What is the question asked? And in science, it sounds like you're being pedantic, but you're trying to actually understand what is your audience. When you're trying to convey something, if this is what you want to convey, then you can using the parentheses and the multiplication. This certainly is clearer, right? I would, if I had to use it on a single line and I had to do operations, right? And let's say I had to use characters, like I'm tweeting this at you. I might do that. Or if I don't have a dot. Or if I do have a dot symbol, I might do like an asterisk, something like that. 6/2 asterisk parenthesis open parentheses 1 plus 2 close parentheses. To me, is more clear. So I mean, you have to be.
Oh wait, Bullinator actually pointed out MV could be millivolts too.
Yes.
That's good. That's right. Again, you have to recognize the domain that you're in. I can tell people so often, even in subjects like philosophy and biology and physics, you have to know the domain of discourse that you're referring to. If not, there's going to be problems with people using words, and people say, well, that's equivocation. It's like, no, I might be using a word in a specific way in a particular domain. Landon might be using it differently in some other domain. There's nothing wrong with that, as long as we understand each other.
But they're using different dictionaries, everything. I mean, if I'm speaking German and you're speaking, or you understanding English, right? We're not going to communicate very well.
Yeah,
right?
But if somebody on the outside says, hey, look, Steve's using it one way, Landon's using it another way, only one of them could be right, that's where they get confused, because
there's a false dichotomy, right?
Yeah, exactly, bingo. They think for some reason, very, very black and white, that it has to be the case whether Steve's right or Landon's right or somebody. No, it doesn't work that way. Again, words convey meanings, but they can be used completely different in completely different contexts in different domains of discourse.
And coming back again to where I was talking about the expressions, right? This stuff here is arithmetic, it's calculations, it's procedures, it's conventions, right? This is very much not what mathematics is about. Mathematics is about computational algorithms, axioms, proofs, all those sorts of systems there. And mathematicians rarely do this kind of stuff, right?
Yeah, no. And by the way, I do agree. People that answer this question on my page, they say it was ambiguous. Absolutely right. I mean, this is ambiguous. I don't think it should be. These should be written these ways, only for the fact it can lead to confusion nowadays. However, students that are taking these types of maths in high school, and well, actually, I guess elementary school, but when they see, this is how it actually is written for them, so they need to pass the test. This is the expected answer for 9. But I agree. I would never use this type of notation because it is ambiguous.
Yeah, but I think in a way that we teach mathematics in a really unfortunate way, in that we do so much. We force people to do so much arithmetic and calculation that they never get around to actually doing any level of mathematics beyond, simple arithmetic. And then the problem is, if at the time you throw out something like algebra, which is like grammar to someone writing a novel. If arithmetic and calculation is spelling, that something like algebra is like your grammar of how you go about doing the manipulations again with symbols, and so you need to have sort of the basic fundamentals. I mean, one of the things to be literate is you need to be able to say what's 3 times 3 and say 9. I mean, you need to have some of the common stuff. Now it's excusable if I say what's 2 to the 81st power, and you don't know. That's where calculators come into play, or that's where computers come into play. But mathematics, this is not what mathematicians spend their time doing. No more than people who write novels spend their time trying to spell words, right? That's not where the effort goes into. And I think when you're trying to teach kids, and you're forcing them to memorize addition table, subtraction table, and do long division, all that sort of calculation and arithmetic stuff, I think you turn them off to what mathematics really is about. Now, you need some of this thing, but I think that you attract where you start to do some very simple arithmetic, very simple. Let them use calculators to aid them in a calculation, but let them get used to it and start to show, hey, when you're starting to multiply numbers, notice this pattern starts to develop. Why is this pattern? Well, that's the mathematics involved in it. And I think we do our society a really disfavor by spending so much time on something as heinous as long division.
Yeah, and by the way, we got to super chat real quick. Odin, $2. Are we talking PEMDAS? I just joined. We already mentioned all that, Odin. But yeah, we've gone over that. But thank you for the super chat.
Thank you.
And there was something else I was going to mention, but I guess I kind of forgot. Oh, if Stuart is still listening, your fixed Stuart, you can actually type, and I'll make your mod. So I don't know how Stuart keeps getting hidden. I don't know why. If you know who Stuart is.
Yeah. But anyway, does
weird.
does that resonate with you in terms of the teaching mathematics?
Yeah, the way I look at it is this: it'd be like arguing this. If we're in an English class and we're going to type, ask how to spell color, right? We're going to spell it COLOR without the U. But in Britain, they're going to put the U in. Both of them are correct, but it's what is standard for that domain. In England, they're going to look for it spelled with the U, which, by the way, I think is objectively wrong. But what do I know? That's whatever. But if you spell it, the Englishized version on a UK test, they're going to acknowledge that's the American version, but you're still going to get it wrong because that's not what they're asking for. That's not what their expected answer should be. That's critical. The expectation of the answer. So yeah, your answer is not technically wrong, but it's not in the right domain that you're answering it. W. Winger, $2. Landon, what's the most dangerous number in Linux?
The most dangerous number in Linux. Well, I suppose there used to be a number that was considered illegal because if you used it and evaluated it as an ASCII string in like Python or Perl, it would be one of the algorithms that was trying to be banned. Like, for example, it used to be that Sony had the CDs were so-called encrypted, and the decryption algorithm, which was really a stupid algorithm, could be expressed as a number. So
I would think it'd be a recursive algorithm that would just tie your system up.
But that's one expression. So but again, it's one of the problems also is that language is a written language, spoken language is full of ambiguity. So if I ask you, Steve, what are chips?
Well, okay, well it depends. Again, in my domain, they're going to be the little potato chips, but they could be fish, or it should be what are they? Poker chips or something. It could be fries.
I was referring to the California Highway Patrol.
Yeah, it could be CHP. Yeah, so. But I mean, it all depends. It's ambiguous, right?
Yes, and so that's why in mathematics sometimes when you see these symbols pulling forward, you say, "Wow, are you just trying to be fancy?" Or no, we're trying to avoid some of the ambiguities of language in conveying things. So when you talk about stuff with regards to things like general relativity or quantum mechanics, we prefer to use symbolic notations because there's greater precision and you have less chance of being misunderstood. Now the problem, of course, with those things is they're not well understood fully to begin with. At least quantum mechanics is pretty well known, but there are things we don't understand about quantum mechanics. It's weird. It's unintuitive, right? So when you try to apply your intuition and written language or oral language to something like quantum mechanics, you're going to run into problems.
We are going to have discussions of quantum coming up. I do have people have asked me. I do have Maddie, who is a nuclear engineer. I have just reached out to her again. I reached out before, but she was busy. But she wanted to come on, so I'm waiting for her response. And I also got another nuclear engineer that I know from Twitter, nuclear Katie, and she's going to be she wants to come on. So I'm going to be getting her to come on with Landon and I for DEF CON 1 one of these days. I've been talking to her. I DM'd her, but I haven't got a response back. But yeah, so we're going to do some nuclear stuff. We're going to do some quantum stuff. We're going to have some pretty cool discussions, I think, on these topics coming up.
By the way, I've been reading the background behind you, and
oh good God, don't do that.
And one of the things is that there's like a parentheses mismatch. So people see the parentheses mismatch over there. Right?
I didn't look at it too closely. No.
I mean, I don't know. It's because it says now. To correct me if I'm wrong here, and maybe that there's something cut off. I'm trying to figure out a logical explanation for something on that set, but it shows expressions, right? It says equals parentheses x sub k plus y slash, and it says x sub k, and it has parentheses n minus 1, and then it has parentheses slash 2, I think it is. And I don't know where this other parentheses is bound to. Is there something on this side? I can't imagine this parentheses
Oh, it's got parentheses mismatch. Yeah.
being
Okay.
closed on that side.
Yeah, and
But
these are things that will drive you nuts. Now, a lot of software will try to interpret it and try to do a closure. I know Wolfram Alpha will try to do
yep.
the proper closure, but because even though it's not noted, there is an explicit open parentheses at the beginning of that.
Yes.
So
Yes. So on this thing here, this subscript k means it usually when you say x sub k, there is a set of values x, and you're dealing with the kth member of it. Like there might be x sub 1 and x sub 0 and x sub 7, right?
yeah,
So x sub k, or whatever the value k is, means it's a member of that set. And we're going to add to it y divided by x plus k, and we're going to take that, raise it to the n minus 1 power, right? So there's kind of implied parentheses here. I know what that parentheses is doing there, and then divide by 2. And this is equal to something on this side.
Reed real quick says $10. Thank you, Reed. He says, I have to use metric and standard as a machinist in the audio industry. I like metric, but construction workers like standard because it's broken into thirds easily. What is best and why? My particular answer is depends what you're using it for. Metric is a lot easier to manipulate, obviously. I mean, it's so much easier to go just move a decimal point and learn your prefixes. Wait, I used to have these memorized, by the way. Atto, femto, nano, pico, micro, millicenta, deca, hecta, kilo, milligigantera, penta, exa, something like that. So pretty close.
Yeah, absolutely. We're good.
Well, I think I messed up, but it's close. I said it too fast, but yeah, but if you know the prefixes, you can manipulate really quickly in metric. But standard, as somebody who was growing up learning standard, I still prefer that system, right? Even though it's weird. I mean, why is like, is it 32 and 212 for water as opposed to 0 and 100? Fahrenheit and Celsius. But by the way, it was based on Kelvin and Rankine. But
yeah,
well, no, Kelvin. Rankine would be on Fahrenheit, right? If I'm not mistaken.
So I prefer metric, and for a number of reasons. However, understand that you might, if you are outside the United States, the Myanmar and some other country, you might run into various problems. Understanding, because when I talk about the problem, of course, I think is that when people assume that the world does it the same way. So if I said, for example, right now, the temperature in my area is 27 degrees, right? And it's also it's reasonably warm.
Yeah, because that's 80 degrees Fahrenheit.
But that's because it's 27 Celsius, right?
Yeah.
And so the problem comes when you sit there and you say 27 degrees and you're conveying that.
But again,
and you assume standard, everyone
right?
is
But
right.
We're American, right? I mean, you live in America, right?
But I converted to metric.
Although he looks Canadian, doesn't he?
When I was 12, back before the stupid senators reversed it and we were going towards metric, I converted to metric, right? When I was 12 years old. And I stayed that way. So if you go in my car, you'll see the speedometer shows kilometers per hour.
So you use all your wrenches are metric, 9mm, 7mm, 4mm sockets.
Yeah, I have that sort of thing, and I've got metric tape measures. Go to a American hardware store and try to find a metric tape measure.
Well, yeah, but I mean he's an auto mechanic, right? So I mean he probably has two sets of wrenches, like a half an inch compared to a couple millimeter wrench. So
and I imagine that there are different automobile manufacturers might be purely metric or mixed or purely non-metric. I'm guessing.
Yeah, but I mean, but it's for the auto industries it would really suck because I mean a half an inch wrench, which I'm used to. I don't think they make a 12.7 millimeter wrench. It's a 12 millimeter wrench, right? You don't get these odd amounts in millimeters usually for a wrench.
Here's the problem: is that you've got a socket set, and you pick out your 17/32 socket, and you find it's just a little bit too small.
Yeah.
What do you go and pick up next?
Yeah, if we go to the next size up, it's going to be too big, and it's hard.
So what is the next size up from 17/32?
Okay, you're making me think here. So. 1/2?
9, is it 9/16?
9/16?
Did I do that right?
I guess you go down the I guess you go to the 16th. You're getting close though.
17.
That's a good question. I don't know.
17 30 seconds. The next one would be 18
32s, which would be
9 16ths.
There you go, 9 16ths. Yeah, okay, that makes sense. Yeah.
So you can memorize all this silly stuff, or you can say, I've got 11 millimeters. What's the next size? Probably 12 millimeters.
Yeah, but that's a big jump.
Right?
Isn't that a bigger jump than 17 30 seconds to 18 30 seconds?
Well, see, a millimeter is approximately there's 25.4 millimeters approximately
I
to
don't
an
know.
inch.
Is it a bigger jump? That's a good question. I don't know.
So that is the millimeter is a step of 1/25.4 of an inch, which is greater than 1/32 of an inch.
9 16ths is 14 millimeter. They said so. Boy, did we get off topic? But yeah,
Right.
The point being, it's two different conventions.
So answer is that if you are probably working on I'm guessing, for example, a Honda motor car, you are probably going to find more metric size things than perhaps a 67 Chevy. Right? And the answer is you got to use both. But here's the thing I think where I think that there's a problem is that when Americans assume that someone says 27 degrees and they think it's cold.
Well, yeah, because they're using a different system, a different convention.
Yeah. Now, so I have to be where and one of the problems that I find as well, because I work with a lot of international folks, and I have interns from all over the world. So when I talk about something, and talk about time, what I find if I talk about time and I say it is 1926, right? Someone writes like that, right? And they say, "Oh, wait a minute, it's not 1926." And this thing here. So if I were being more precise, I might say Pacific time. And of course, depending on what time of year that might be, and whether you're in one of those daylight savings time challenge stuff, that might be something. So I might end up saying something like 2019, and then I'll say something like August 12, right? Pacific time, right? So I'm telling somebody. Now, of course, the problem is that there's a lot of people that see 1926 and they think it's 9:26 p.m. Right? Because some people, when they see this number here, they think I'm going to show up at 9:26. But so one of the ways you could do that to be even more precise is, it's redundant, but you say 9:26 p.m. Because now everyone does this AM PM stuff.
Well, because it eliminates, like I said, eliminates ambiguity. Real quick, by the way, yeah, it's -40 would be the same for Celsius and Fahrenheit. So if you say -40, it's -40. You could be in either one. Now you could also argue, well, it means something in Rankine and Kelvin different, but yeah, who uses Rankine though?
Oh, I don't. I mean, it probably is in old text, but I don't think it's.
Well, it's kind of like Rankine is kind of the equivalent version of Kelvin, only on the Fahrenheit.
So someone writes that, right? Or you might say, well, what is that? What is 8/12?
What you mean, reduce it? 2/3.
What is that? No, that's how some people express August 12th.
Oh, okay. See again.
Now the problem, of course, I think it's really stupid. I don't like to do it this way, right? They'll do this. Right, type of thing, right?
Yeah.
And I think that's a really poor way to write stuff.
How about
they'll even do?
What did we do in 2019? What did you put, like 8/12/2019? That's how I write it, by the way.
Right. So I think that's a poor way to do it, because in many places in the world they do day, month, year, or they do year, slash month, month slash day, day.
Yeah, and certain programs will do it differently too on your spreadsheets
So
and things
eighth,
like
well,
that.
some people
So,
say, well, that's
yeah.
the 8th of December. And some people will say, well, no, that's is it the 8th of December or is it the 12th of August?
Yeah,
Right?
it's like
And
confusing.
and sorting, I think it's really bad when someone sits there and they'll say August 12th,
See, I go
2019,
month, day, year.
right? Because that doesn't sort well. I mean, it's like if you're doing 4 and 20 backbird stuff,
Yeah.
right? I think that's a poor way of doing it. So the problem, of course, is that if you say 2019, 8, 12, like that, is that year, month, day? Is that year, day, month? Right? So oftentimes I will come and try to say, well, since we're doing an English language, I'll do that to make sure that's a month, that's a year, that's a
It
day.
deambiguates.
It does something. Now there's an ISO standard, by the way. ISO says we'll say either that you're doing it this direction or you're doing that direction, right? So some people, if you're sorting stuff, right? You have sorting a list of things. I think you're much better off using this kind of notation, right? That you do if you've got a timestamp, 4-digit year. Don't do that Y2K silliness, right? Dash dash DD space HH colon colon SS time zone, right? And you can at least begin to sort this in a rational fashion as opposed to that. And of course, someone might do, instead of MON like that, the name as opposed to the digits. But if you're doing pure digits, you're better off doing year, month, day, hour, minute, second, or this is the leading stuff. And you sort by the year, then the month, then the day, hour, minute, second.
My unfinished journey asked for 5 super chats. She says, I think it's just she, right? We need base 12 math and a measurement system consistently based upon base 12. Thoughts? That's a duodecimal system. So she's advocating from decimal to duodecimal. What do you think? A lot of people like that system. I don't know.
I don't think that the base 12 stuff, because of this notion that you can divide by 3 easier.
You still run into a problem with all systems, especially like repeating decimals. It's like
because at some point you say, well, what about when you divide by 5? Well, why do you want to do that? Right. So it's get used to the fact that you're going to have things that are not even multiples of something and go forward. So
J Rod had a super chat for $2 too. Thank you, J Rod.
Thank you.
Okay.
If you think, but I do appreciate you're supporting this channel, because you can get useful things like this.
Yeah, this is a free lecture from Landon.
I will say
like,
so when I'm talking with somebody, right, and we're gonna meet. This person's in London. I'm here. I'll say 2019, October 12th, 1926, 9:26 p.m. Pacific, right? I'll go on and say that to try to minimize, because I don't want that person to think I'm dealing with London time, which is different than that London time, because London time they can be on summertime and we're not. There's all that of when to switch over and so forth. So at least they can look up and say, what's Pacific time right now, and I understand. So what you're doing here is you're really saying 7:26 p.m. You notice how that's set there and no one corrected me?
I barely can see it. Yeah.
Right, 1926. I'm sorry. Do I need to write it lighter? Or write it larger?
Oh, I'm also looking at the live chat too, so I got some super chats that I got to read. I missed.
Yeah. So just notice, by the way, that's why, because that was not 9:26 p.m. That was 7:26 p.m.
S. Winger says $5 now. If somebody wants their mind blown, learn about reverse Polish notation, interpreters using Haskell. Try without an accumulator.
Yes.
So a lot of I don't. By the way, I only had to use reverse Polish notation on what was it, an HP calculator. Yeah, I forget it. I'm not gonna bother. But yeah, it's that's a whole different ball game when you're using an accumulator and you have to push it on the stack. My unfinished journey, $2. Base 12 math for the win. guess they really like base 12 math.
I don't think there's any. I don't think the need to divide by 2, 3, and 6 is so special that we have to do things in base 12.
Yeah. And by the way, Brian Moher says, "Can you tell him it's supposed to be?" And then he actually gave the actual equation for the one that was on the back of the here. So it'd be x sub k plus 1, and then the rest parentheses. He figured out what it actually should be.
Oh, okay. Because k plus x, y
plus y over x raised to the parentheses n minus 1. I don't know, but he figured it out.
Okay. Yeah.
One of these days we might have to get into some things like.
So this is why when you're writing stuff and you're writing in 24-hour notation, some people look at that and correctly you will say 9:26 p.m. when you say 7:26 p.m. here. So that at least helps people understand. You have a better chance that this is the problem that there's a lot of people when you say I'm going to meet you at 13:30. They think, oh, well, 3:30 p.m. No. And so this AM PM thing, what I don't like about this is if it's 11:59 a.m. and it go 1 minute more, what is the next minute?
It'd be noon. Which is noon.
Which is PM. I think that's it. So if on the other hand you were just doing 11:59, the next one is 12. There's none of this.
Which could be, but that could be actually midnight.
Yeah. So if you said 11:59 p.m.
Let's probably use military time, 24-hour. And by the way, Rez, thank you real quick. Rez says for $10 Australian. Sup, peeps? Thank you, Rez. By the way, Rez, I think Rez donated. If it was you donated a game, I did get it. I'm backed up on my games. I will play it. I promise. I'm just a little bit backed up on them. Yeah. So if that was, I think Rez bought me one, but I do appreciate it. But Reed, $2. I'm a machinist, not a mechanic. Just saying, LOL. Okay, so you're right, and there's a huge difference, by the way. Machinist is a lot different than a mechanic.
Yeah,
I was qualified. I was actually qualified. I was a machinist mate, but also was qualified propulsion plant craftsman and machinist. There's a machinist rank, and I don't remember what it was called, but we had a machine department that had the lathe and the whole 9 yards. And normally I would just tell people what I needed, but every so often I had to run that stuff. And I got to tell you, as a machinist, when those shards that come out when you're drilling something, those things are got to be the sharpest, most razor things I have ever seen in my entire life. You can nick it and that will slice you. I hated doing that stuff.
Yeah. Really good machinists, and also like glass blowers and so forth, are really fundamental to a lab, and they do amazing things, amazing precision for items.
The tolerance, it has to be like 1/1000th of a millimeter. A couple more things here. By the way, Mind Onion wants us to do a discussion one day on summations and maybe the Zeta-Riemann function. And function renormalizations. Okay, great.
Yeah, infinite series and infinite sets and
we might
sequences,
be able to do something like that.
Sequences, that sort of thing. But anyway, so again, be careful. So I would ask if you're going to insist on using Fahrenheit, at least have the courage of the rest of the world to say Fahrenheit, right? Say 80 Fahrenheit or 80 F, not 80 degrees.
Yeah. Couple other super chats real quick. Vibrant Brantley, $1. Thank you. I think that's when I see usually the $1 super chats. Those are the people I think have read YouTube Red, and they get like $2 a month to donate to their favorite channel. So I do appreciate when I see those things very much. That means they're actually using that $2 for this channel, and I appreciate it, or $1. But let's see here. Planner Rock, $5. I think New Zealand. I think NZ. I'm not sure what that is, but Planner Rock. 2 questions for Landon that give top flirts trouble. If I have a triangle with one sides 1, 1, and 1, an equilateral triangle with 1, 1, 1, what are the angles?
Well, the question, of course, is if it's in a plane.
We'll assume Euclidean in a plane.
Yeah, Euclidean and Euclidean. Then you'd have 60 degrees, right? If you talk about on a plane in R2. Where this is 1, 1, and 1, that's a triangle, then you'll have 60 degrees.
So 60, 66, because it has to be 180 on a flat plane. And
Yes.
I love this one. This is actually my favorite because this was a flurfer that actually advocated this, and I still can't wrap my head around it. He asked, okay, write this on the board. 10
10.
raised to the
Yeah.
negative 17th.
Negative
Yeah.
17.
Is that a positive or negative number?
That's a positive number.
Not according to the flurfer.
Wow.
I think that's a negative number. Who was that? Was that Anthony Riley or was that?
Well, it's obvious. You multiply 10 by itself negative 17 times.
You just said, okay, do you realize you just said it's obvious when we're talking about a flat earther? Dude.
Yes, it's obvious. It's 10 multiplied by itself negative 17 times, right?
Oh, God. Yeah, there was a flat earther that actually believed. We got a couple of super chats. Holy cow. Gabber, $5. Year / month / day is now how we do it in Hungary, and your family names come first. Ed Teller, my hero.
Yes. So this, I mean, sometimes people will do this right there with a slash, right? I guess the question, of course, is that, and some, I typically try, because people see slashes and think, because again, with symbols it's kind of obvious, but again, if someone says 10/17, right? Then the problem is that month or is that year? Well, you say, well, okay, it's kind of obvious that it isn't a 17th month.
Right.
But if I do 10
yeah, I don't know what system that is.
/3, but if you saw this 2001/9/10/3, you might say, is that year, month, day, or is that year, day, month?
Yeah.
So if you did, so in an ISO timestamp, they'll do like this, right?
Couple of real quick. Jen's $2. Perl is the only elegant languages for math. Perl is one of the only. I think they mean the Perl is one of the only elegant languages for math.
Yeah, I like Perl. I'm a big fan of Perl, and I think one of the reasons why I'm a big fan of Perl is Perl plays well with others. There is another language that begins with P that doesn't play well with others. But
it integrates well with other scripts, other languages.
It assumes that there's only one way to do it because the person who wrote it assumed that there's only one way to do it.
Oh. Bullinator, $5. Bull, math is fun. Yes.
Yeah. So Perl is nice. We're
gonna have to get Bull to produce one of these things. Vibrant again, $5. No, I only felt like giving you $1, but I'm on RedTube a lot. Oh, thanks, bud. Yeah, the $5 super chat to say that. Thank you, Vibrant. That's funny, actually.
But anyway, so if your lab has a good machinist or a good machinist shop, you've got a really great asset there. And
we didn't have any of that back on the Navy when we were doing the machine shop. We didn't have these computer lathe things where you did all that mathematical stuff and you wrote the script for it and did it. You had to basically measure and cut and
just like a good
when you're fabricating something.
A good glass blower that will create.
I couldn't do any of that stuff. I was never good at it to begin with. I hated welding. I hated lathing. I hated all that stuff. I was the worst machinist mate of all time because I really despised it. Matter of fact, I didn't even like replacing gaskets. I hated all that stuff, to be honest with you.
Yeah, on there.
So, anyways, you are getting close to the 2-hour mark, and I do want to keep this under 2 hours so it's easily adjustable. Plus, it renders faster.
Any other folks that any other questions?
Questions in here.
And again, I apologize for the typos up here. I'm glad people. And by the way, I did introduce some deliberate typos, and it was too bad that no one caught the 7:26 p.m.
I kind of like doing a million different things. S. Winger wants to know if you can explain the difference between descriptive versus prescriptive languages. So
think about that prescriptive prescribes. It says this is something that this is a prescription you must do. Descriptive stuff will say essentially that they're trying to. So for example, a dictionary. Most dictionaries are describing the language at the time the dictionary was created. right? So if your dictionary does not have the word THRU, you can't say, well, that's wrong because it's not found in my dictionary. Your dictionary may be old enough that this word, this spelling for through, was not in its dictionary. If you have a comprehensive dictionary of the English language today, THRU is one of the words, one of the spellings that should be found in it. Now, it's okay to say that THROUGH is preferred if you want. But that's, even that preference is not saying that that's wrong.
See, I will switch between the two sometimes, and I'll think, am I using which one should I use?
So describing, a dictionary describes the language at the time, right? If you want to have a formal definition to state, for example, if you're dealing with an ISO standard on how light bulbs are constructed, they won't describe how a light bulb, they'll prescribe how a standard light bulb is created.
Yeah, and
you would have a light bulb.
Oh, sorry. I would just say that a prescriptive option would be like in math, when you have a formal definition for something, that's prescribing it. It's not describing the uses in math. It's telling you this is what that symbol means.
Yeah, and don't confuse dictate with descriptor, right? Prescription. It's like someone's handing the doctor hands a prescription to the pharmacist to prescribe a particular medication. They don't sit there and describe saying, well, Madam Pharmacist, please get find a pill that's kind of blue that makes them feel better.
Yeah, I would kind of look at it as, like, for example, when we get into like set theory, we might talk about, and in when it comes to the rationals, this field of Q is a very specific way it's defined, like P over Q, when your denominator is not 1, and it's prescriptively defined that way.
Yeah. So, but when I write through like this, THRU, and someone says, you spelled it wrong, it's supposed to be this way, I first of all say, well, you already recognize that was through. So I communicated to you effectively. But you happen to use a dictionary that only has that spelling in it, and that's your problem, not mine.
Yeah.
Right? Dictionaries describe a language.
This is why argument from dictionary is so bad. Dictionary is not telling, and I've said this so many times, and people laugh at it. They're like, Steve doesn't know what he's talking about. Dictionaries do not define words. And what I mean by that is they do not prescriptively tell you how a word is to be used. It's telling you synchronically how the word is being used at the time.
Yeah.
There's
so, for example, the Oxford English Dictionary is a marvelous description of the history of words. And if you want to know about THRU, go to someplace like the Oxford English Dictionary, because they will tell you the first known use of THRU and its history, right? A history of how a word is used. And so
that's called diachronic, by the way.
Yeah.
So you have synchronic versus diachronic.
Yeah. So so I think if you talk about a standard and you're trying to describe how the TCP protocol works, you will have a prescriptive set of terms, and they will have some very explicit terms that have very explicit meaning. So when the standard says the word shall, or must, they have a very, very, very specific meaning, and so standards tend to be the normative part of a standard tends to prescribe how to do something in a standard way. They might have informative annexes to give you more thing, because sometimes the formalism gets so unwieldy that it's hard to understand what it is.
Yep.
So again, descriptive describes something. Prescriptive, if you will, prescribes exactly, if it's good, how something is done.
What I suggest to people, because we are going to be wrapping this up, if you guys want a specific topic to be talked about, I do know a lot of people, and even the people that I don't have an expertise in certain fields, they're more than competent to talk about a lot of different things. So if you have a specific topic that you want to have discussed, put it in the comment section. I will see what I can arrange. I'm going to be bringing in guests. Obviously, I'll be doing these things, frequently. Tomorrow morning, we are going to be doing Caffeine Corner. We didn't do it today. I slept. I was just dog ass tired. Not going to front.
Yeah.
But we're going to be doing that tomorrow. And then we're going to be trying to have some nuclear stuff coming up. But if people in the live chat, if you want to do something like say, hey, let's have a discussion on, like I'm thinking about doing one on matrices. We'll do ones
Sure.
on rings. We'll do one on maybe summations. Not too in depth, but obviously superficial where people can understand these things because that's the only level that I have of these things as well. But I would love if people would. I didn't think about something. I'm like, man, that's a good idea. Let's do a discussion on that. So please, in the comment section, let me know what you think that you want to do. I'm game for a lot of this stuff. These are my favorite types of discussions. Trust me.
Yeah. Any other questions that people have there?
Yep. So last call, we got about 10 minutes here at most before we gotta wrap this up.
So one of the things you talked about in terms of grammar, right, versus style, right? Someone might say you must not end a sentence with a preposition.
Oh yeah, that doesn't even apply any longer.
Right, and what
or split
what
infinitive.
happens is that people were describing a style that they did not like, or you can't split infinitive, right? You can,
Yeah.
Right? The question is that a good use of language? If it conveys things in a reasonable way, that's reasonably and unambiguous, and you want to be unambiguous, then go
The
for
rule
it.
of thumb for a writer is write how you feel, and if there's reasons to use convention or even off convention, if you understand the topic, you'll see writers do things that are grammatically incorrect for reasons sometimes. But even then, when you have these rules that I grew up with, saying you don't split infinitives, you don't have a dangling participle, things of that nature, they're not even applicable any longer.
Yeah.
They're these are just conventions.
Yeah.
So they're not
So
like
the
hard in
passive-
stone.
Exactly. The passive tense is a perfectly fine voice to use in the English language. However, if you are trying to put down, you're trying to prescribe how to bring up a virtual machine on a Red Hat Enterprise Linux box, you do not want to use passive voice, and you want to be very explicit in who is the actor and what they're doing, right? So you should tend to, in circumstances, avoid the passive voice when, in fact, you're trying to be very prescriptive.
Why don't you write some code for Cortana so when I want to be able to like say open this and write a code, and I've seen them trying to work on something like this, but write it so I could write some script to say when I say this word, run this script, and she does this. I know they've tried to work on it, but it's just nothing convenient. How come they don't have a program like that where for the average person you say, okay, what program do you want to open? I mean, you can do it all like even in Visual Basic. It'll do it for you. It'll write the script for you. You just do it in a form. Say what program do you want to open? What do you have any parameters for this? Blah blah blah. It wouldn't be that hard to write something like that in Visual Basic.
No.
Now, granted, I don't write in VB any longer. I used to. I wrote a database program for Radio Shack one time for RSU Unlimited, which is the shipping type thing for my store. I wanted a better way to track them, and so I wrote a program that you put the person's name in or their telephone number. It would search the database, find the information, and then display them the whole information for them. So like kind of like a Rolodex program that I actually had written for college that I modified for VB. But I don't do any programming. I haven't programmed for years, so I understand the concepts of programming. But the language is I forgot the entire language. I just don't remember it.
Yeah, and
so many
it
things
might
to remember.
Let's say you're talking about you have a home assistant and you want to talk about I want to leave home and lock up, right? Then you would say, well, what does the locking up mean? Well, it might mean that you're going to go and lock this door and set the alarm and lock this door, but it's going to check this. So you would teach it. What does it mean? I'm going to go to sleep.
Yeah, how do you do that? I think that Cortana should be more teachable.
And so you say Cortana or Siri or whoever is there, thingy. Going to sleep means turn off all the lights except for the night light, turning down the stereo to a soft, whatever you explain what it is. So when you say, okay, I explain how I want to go to sleep, then say, assistant, I'm going to sleep. That means to do.
So why can't we have a program like that?
I think so. The challenge, of course, is that the ambiguities on there. You have to be careful because if you said, all right, if going to sleep means doing something with the lights, doing something with the sound, and locking the doors and turning on in exterior alarms and that sort of thing, you want to be able to convey that in a way that's easy. I think I think that needs to be done because people, when they say, autonomous car, drive me to work, they don't have to sit there and say, autonomous car,
I just want
start the engine,
I
release
just want
the
something
brake.
simple, Landon. I
Yes,
want to be able to say, hey, open this particular game, and she does it.
sure,
How
sure.
hard can that possibly be? All right,
Okay,
but
so I think it's called, it's called, and you want to have something like macros. So if you sit there and say, assistant, start this
you could
game.
write a macro too, right, for that. So
Yeah,
and she recognizes that game. Like I think it'd be easier to say, I want one word to say, if I say this word, this is the game I want to open. But you can also write it as a macro form as well, and
yep,
say open, and then whatever your variable for the game is.
sure.
But anyways, my fitness journey, $5. So Landon is saying that the passive voice should be avoided in that context.
I think if you're trying to be very clear as to who's doing what, and you're using the passive voice, you run the risk of being misunderstood,
Gotcha.
right? If you say, and like in that context, right? You're talking about this as assistants, and you say, it turns off the light. Is it the assistant turning off the light, or is it the switch control turning off the light, or the cat turns off the light? I mean,
Yeah.
what's right? And which light? So you want to be very explicit. I think it's easier on that sort of system, if you're talking about assistant or verbal stuff, to give non-passive command.
Yeah. Well, Alexa, I think Alexa can do it. But yeah, I don't have Alexa. I want Cortana to do it. That's what I have on Windows. And I use it for everything. I use it for scheduling. I like the fact that when I schedule something, I can say, "Hey," and then mention her name. I don't want to say it because she'll
Yeah.
come up. But
And
I
and
have
I would
active listening. But you can say schedule this, and she'll say, "Okay, what would you like me to schedule? What time? What day?" And then the event name, and boom, it's in my
yeah.
Google calendar, and I like that. And then I can ask her, "Hey, Cortana, what do I have scheduled on this particular day?" And she'll say, "I found this for you." I have to keep track of that because I try to make sure that when I schedule people like this for Landon, I don't stand him up, right? Eventually it might
Yeah.
happen, but Landon's always prompt, right? I mean, when I schedule Landon, he's going to show. And I want the same thing for me. When I schedule something with Landon, if I don't show up for some reason, obviously Landon's going to go, "Hey, something came up," and I get that, and I
Yeah.
will explain to him. But I try to make sure that I don't forget anything, so I do everything with my schedule program. But anyways, we do got to wrap
Yes.
this up. I'm going to throw this out in the live chat. I want to thank all the people that are watching, all the super chats, and I want to
Thank you.
especially thank my Patreons. $1, $2, whatever it is a month, I appreciate every one of the Patreons. It's gone up significantly.
Please support this
I
channel
and I got
if you want this kind of stuff.
thanks to the help of Landon and some benefactors, I got an amazing computer now where I can do a lot of this stuff now. And I want to put forth the content that should be from this channel that my Patreons deserve and my benefactors for this computer deserve. This kind of quantity, or excuse me, this kind of quality for this type of hangout is what I love. I think these are the best discussions, and we're going to be doing a lot more of these things with a lot of different people. So,
And I'm 95% certain.
For $1 a month, or $2 or $5 or $1,000 a month, whatever, a million.
And I'm 95% certain I made errors, and if so, I apologize for those errors there. But hopefully you found the facts out of the fiction.
Awesome, Landon. Thank you. Always a pleasure. And I want to thank some of my other co-hosts that are coming in. I got Sarah, and I got Chesh, and I got Nick. I've got Mikey might be coming in for a few, and I got Jim Major,
And all those
a whole bunch
people
of
in the
people.
future that are yet to watch this, hi.
Good night, all.